8.2, solving problems that involve rates. Example 1 says Jason lives in Abbotsford. The gas tank of his truck is 135 liters. He can either buy gas in Abbotsford at $1.20 per liter or in Sumas at $4.55 US per gallon. So there are 3.79 liters in a US gallon. Which option makes the most sense economically? So which one would make the most sense for us to buy? So first we need to convert dollars, Canadian dollars to US dollars. So let's say Canadian's $1.03 for a US dollar. To be more exact, we could look that up, but let's say $1.03 Canadian is $1 US dollars. So in Abbotsford, it's $1.20 per liter. But in Sumas, we're going to have to change our currency. So if I have 1 gallon, $4.55 per 1 gallon. And we know that 1 gallon is 3.79 liters. Then these would cancel each other. And we also need to change currency, so times $1.03 Canadian is to 1 US dollar. So US cancels. This is US. In the end, that's just showing all of our conversions at once. So I will have $4.55 times $1.03 per 3.79 liters. Simplifying all of that, we want per 1 liter. So dividing the top and the bottom by 3.79 is going to be $1.24 per liter. So comparing $1.20 per liter or $1.24 per liter, Abbotsford makes more sense. It's less money for the same amount of gas. $1.20 I'd be paying in Canadian versus paying $1.24 in Canadian after I did that currency exchange. Example 2. A faucet leaks 1 milliliter per minute. How many liters are wasted in a week? So again, we need the same units. So 1 milliliter per 1 minute. Times minutes to hours. So 60 minutes in 1 hour. So my minutes are going to cancel. Now, how many hours in a day? Because we need to get all the way to a week. 24 hours in 1 day. My hours are gone. Times 7 days in 1 week. And days are gone. So I'll have 1 times 60 times 24 times 7 milliliters all over 1 week, which ends up giving me 10.08. Oh, I missed one conversion. It asks how many liters. I missed that word. How many liters? So one more here. 1 liter is 1,000 milliliters. So my milliliters will cancel. And this will be over 1,000. So that's where 10.08 liters per week comes from. So all I did was multiply anything that I would have in the top. 1 milliliter per minute. 60 minutes in an hour, 24 hours in a day, 7 days in a week, and 1 liter, because we're trying to get to liters, is 1,000 milliliters. So my mills canceled because I needed to write my answer in terms of liters. We need how many liters in a week. Cancel off all of our units. We're left with weeks in the bottom, liters on top. Multiplied all my numerator values. 1 times 60 times 24 times 7 times 1 was 1,000. Or sorry, it was 10,080. And then we divide by 1,000. So that's how I got my 1008 liters per week. Example 3. Miss Steen is asked to order snacks for a staff meeting of 60 people. She decides to order cookies, which come in boxes of 12. She estimates she's going to need 2.5 cookies per person. How many boxes do I need to order? So 2.5 cookies per one person. One box has 12 cookies. So cookies is gone. And I have times 60 people. So my people persons cancel. So 2.5 times 1 is 2.5 times 60 is 150 over 12. 150 divided by 12 is 12.5. 12.5 boxes is what we're looking for. Can I order 12.5 boxes? No, so I'll have to round up. I'll have to for sure get 13 boxes. Part B, so that was A. B says, if each person actually, how many boxes of cookies will be left over if each person only eats 1.5 cookies instead of 2.5. So 1.5 cookies per person. And we said one box has 12 cookies, just like above. Still 60 people. Gives us 1.5 times 60 divided by 12 is 7.5 boxes. So if I bought 13 boxes from part A, and I'm going to use only 7.5 boxes when everyone only eats 1.5 cookies, I'm going to have 5.5 boxes left over. Example 4. Shayna walks 6 kilometers per hour and burns 454 calories in 2 hours. Zach walks 4 kilometers per hour and burns 62 calories in 30 minutes. If Zach walks for 2 hours, how long does Shayna need to walk to burn the same amount of calories as Zach? And we're going to assume they're going to walk at their respective rates that I mentioned before. So how many calories first does Zach burn? We need to figure that out. I know how fast he's walking. He walks and burns 62 calories in 30 minutes, and he's going to walk for 2 hours. So we need to figure out how many calories is he burning altogether. So for Zach, 62 calories in 30 minutes. Well, there's 60 minutes in 1 hour, and he's walking for 2 hours. So hours cancel, minutes cancel. So our answer will be in calories. 62 times 60 times 2 divided by 30 is 248 calories. So now we need to figure out how long does Shayna need to walk in order to burn that many calories. So Shayna needs to burn 248 calories to match Zach. She burns 454 in 2 hours. So in 2 hours, she burns 454. Not 254. Calories cancel. 248 times 2 divided by 454 is 1.093 hours. Or, you know, 1 full hour, 1 hour, and then 0.093 times 60 minutes to figure out what is that, how many minutes of an hour would that be? And that is 6 minutes. So an hour and 6 minutes, or 1.093 hours, is how long she'd have to walk to burn the same amount of calories as Zach. Example 5, Kaylee can paint a room in 4 hours, while Ailey needs 6 hours. How long does it take to paint a room if they work together? So this is similar to the tables that we did in our last section. So from 7.8, when we were comparing work rate, like the cold water tap takes so long and the hot water taps takes this long, how long would it take together? So Kaylee can do 1 room in 4 hours. Ailey can do 1 room in 6 hours. Together, they'll do 1 room in X hours. We don't know how much. So if we were to write this in terms of just fractions in an answer, so 1 over 4 plus 1 over 6 equals 1 over X. In order to add fractions on the left-hand side, we need common denominators. So let's make it as 12. Multiply this by 3, by 2. So I have 3 over 12 plus 2 over 12, which is 5 over 12, equals 1 over X. Cross multiply here. 5x equals 12. Divide by 5. X equals 12 over 5, or 2.4 hours. And then same thing like our last example, I could do 2 hours and 0.4 times 60, which is 2 hours and 24 minutes. When I do 0.4 times 60 would give me my minutes. Your assignment for 8.2 is on page 466, number 1 to 4, 6 to 8, 11, 15, and 16.